Hello everybody and welcome back to our visualization session with Matplotlib. So in most cases a graph tells us more than a bunch of numbers, and for the human eye a graph is typically more intuitive and understandable, and therefore also Python has an extensive library for visualization called Matplotlib. So there are actually no limits in customizing graphs with Matplotlib, and you could actually re-engineer or redo any graph you might think of in Python, and it's just a matter of time because the functionality of Matplotlib is more or less unlimited. So this session should serve as a short intro that enables you to make the most common plots like line plots, scatter plots and histograms, and it should also enable you to make the most common and important customizations to plots. So first of all we have to import the plotting framework of Matplotlib called pyplot. So we import matplotlib.pyplot as PLT. So this is a standard convention to have the abbreviation PLT. And if you work in Jupyter Notebook, we should also have here the magic function matplotlib inline. So let's execute here. And then first of all, let's create a list with 5 elements, 1, 3, 5, 7, and 9. And we want to create a line plot of these values, and therefore we are using the function plt.plot for the line plot, and we pass our list to plt.plot. And before we want to execute and show our line plot, we also should use plt.show. Let's execute the cell here. So now here we can see our line plot. So when looking at the y-axis, we have 1 here, then we have 3, we have 5, we have 7, and we have 9. We could also change the last element here to, let's say, 6. So here in the end then we have 6. And by default plt.plot starts with 0 at the x-axis. So this is actually an interpolating line for the points 0, 1, 1, 3, 2, 5, 3, 7, and 4, 6. And we can also define x-axis values. So by default Python assumes integers starting from 0. And here in this case we have 5 elements, so from 0 to 5 excluding, so this is in the default case. So we get here the same graph. But we can redefine the x-axis, so let's say we want to have x values from 5 to 10, we can do this. So now the x values are starting from 5 till 9. So and if we cross out plt show, then we can still see the plot here, but also we have here a description of plot object, and therefore it's a best practice here to have the plt show before we plot here. And we can also make a scatter plot with the function plt.scatter, where we define x values, so from 0 to 4 including, and the y values is our list. So let's see what we get here. So we get here scatters, and the first one has an x value of 0 and an y value of 1. And the second one has an x value of 1 and a y value of 3. And the third one has an x value of 2 and a y value of 5, and so on. However, we have to keep in mind that the amount of x values must match the length of our y values here. So if we have, for example, x in range 7, so we have here 7 elements of our x-axis and only our list L with 5 elements, then we get an error message. So x and y must be the same size. Alright, so let's move on to a histogram, and let's assume that we are standing downtown New York at a street with the speed limit 50 miles per hour. And we are measuring the speed of 10,000 cars. And for our purpose here, we assume that the speed is normal distributed with mean 55 and standard deviation 5. So we are creating 10,000 normal distributed random numbers with mean 55 and standard deviation 5. So we are using here a list comprehension, and we are assigning the variable speed to New York. So actually the length of our list should be 10,000. Okay, first of all we have to import the random module, then it should work. And we can also check some elements here of our list speed New York. So let's check the first 10 elements. So we have 54, 55.4 and so on, 48. And then we want to create a histogram with our 10,000 measurements, and therefore we are using plt_hist, and we are passing our list speed New York to plt_hist, and we are defining that we want to have 100 bins. So let's see what we get here. So here we have a histogram with our measurements. So it's no surprise, as we created our measurements with a normal distributed random numbers generator. We get here kind of a bell-shaped curve with the mean at 55 approximately. And we can also change the amount of bins. Here we have 100 bins, and let's see what happens if we change it to 10. So now we have only 10 bins, so that's maybe not the perfect solution here. So maybe if we increase it to 1000. Yeah, this is maybe also not the best solution. So 100 bins for 10,000 measurements should be a good solution here. And now what we can do many customizations. So first of all, so let's plot again here. We plot our histogram. We are passing our list speed New York. We are having 100 bins. We are setting the label to New York data. We will see later what this will bring us. And also we set alpha to 1 and the color of our histogram to red. Let's draw the graph here. And it's essentially the same graph as above. We only changed here the color to red. Yeah, and then we can make here customization. So first of all, we can change the style we use to Seaborn style. So here there are many styles in Matplotlib, and it's more or less a matter of taste which style you want to use. So if you change it to Seaborn, then it looks a bit different, a bit more scientific actually. And we can also change the size of the figure by using the function plt.figure and set the fig size to, let's say, 10:6. So now it's a bit larger. We can also change here, let's say, to 12:6. And we can also add a title to our graph with the function plt.title. And then we need to define the title as a string. So here measured car speed, speed limit 50 miles per hour. And what we can also do, we can set the font size. So the font size could be 15 here. So it's a bit larger than the axis here. And then we can also introduce labels for the axis. So we can introduce a label for the x-axis with plt.xlabel and pass the string speed. So now here we have speed. And the same we can do with the y label. And for example, we can set the label occurrences, number of occurrences here. And we can also plot the vertical lines with the function plt_vlines. So the purpose here is to draw a vertical line at the mean value of our collected or measured data. So here let's see, Shift-Tab, what we need here. So we need the x value, and this is the mean value of our list speed New York. So we take the sum divided by the length. And then we also have to define the minimum y value and the maximum y value. So here we can set it between 0 and 400. And then we can define that the color should be red and the line should be here dashed, and the label should be mean New York. So let's see what we get here. Here you can see we can see the dashed line. But as our histogram is intransparent, we cannot see our dashed line here, and therefore we have to change the alpha of our histogram. So alpha equals 1 means there's no transparency of our histogram. So if we change it to, let's say, 0.5, our histogram here is getting transparent, and then we are seeing the vertical line here. Next we can set the range of the axis. So here with plt.axis, and let's see what we need here. So we have to set xmin, xmax, ymin and ymax. So y should be between, let's say, 0 and 400, and x should be between 30 and maybe 90. So let's run here. And then we can also set the ticks of our axis. So to say, here we have ticks at 30, 40, 50. And if you want to add ticks at, let's say, 30, 35, 45, then we have to change it here. So from 30 to 91, we want to have ticks at every fifth value. So here we are. And the same we can do with the y label. So here it makes sense to have ticks at every 50th number. So we already have it here. And then we can define if we want to have the grid here or not. And by default, with the seaborn style, it's enabled. But we can also disable it with false. Let's make it true again. And before we had here in our histogram, we had the label New York data, and in our vertical line, the label mean New York. And to show the labels, we have to call the function plt_legend. And with plt_legend, we can define the location of our legend. So let's enable it here. And let's press Shift Tab. So here are location strings, so you can pass best or alternatively 0, or upper right is 1. Here I have center right is 7, and so on. And we also define the font size equals 13. So let's see what we get here. So now we have here our legend. And we can also make many more plots within one graph. So let's assume we are going to Boston and also measure 10,000 times the speed in a street with the speed limit 50. So let's assume the Boston people are driving faster and on average 60 miles per hour in a 50 miles per hour zone, and with standard deviation 8. So let's create here the random numbers and store it in the list speed Boston. And then we can also plot the histogram here from Boston. So plt_hist, we pass speed Boston, we set bins to 100, set the label to Boston data, alpha equals 0.5 and the color to blue. And let's see what happens. Yeah, here we have both histograms from New York and from Boston in one graph, and it makes it very easy to compare. And we can also enable here the vertical line at the mean of the Boston data. Yeah, and here we can see on average, the Boston people are driving faster than the New York people. And also the variability of the Boston data is a bit higher, so it's a bit more diverse here, because the standard deviation of our Boston data was higher with 8. Alright, we are finished now with our short introduction to Matplotlib, and if you want to go deeper into details, I recommend you to go on the documentation side. So here you can find many examples and tutorials, and if you have a look at the examples, so you can see here, yeah, the options are actually unlimited. So there are hundreds or thousands of examples here. So have fun if you like, and I hope you enjoyed this session, and yeah, take care, bye.